we will do revision of light chapter today. Light and phenomena, only two phenomena of light, reflection and refraction. Okay, what is
Mm.
reflection? Reflection is bouncing back of light in the same medium after striking a surface. Okay,
Yes,
if
ma'am.
this surface is smooth, then regular reflection takes place. Correct?
Yes, ma'am.
And if surface is not smooth, it is like this one, then also reflection takes place, but it is not regular, it is like random type. Okay,
Yes, ma'am.
reflection has two laws. In first law, according to first law, firstly I will let you know one more thing. Incident ray, reflected ray, angle of incidence, angle of reflection. Tanya,
Yes, ma'am.
this one, like smooth surface and ray is coming here, this will be known as incident ray, and this one is
Reflected.
reflected ray. One imaginary line which makes 90-degree angle with the surface is known as normal.
No.
This one is incident ray, this one is
Reflected.
reflected ray,
Ray.
reflected ray, and this one is normal.
Normal.
Angle Angle formed between incident ray and normal is known as angle of
Incidents.
incidence. Angle formed between normal and refracted ray known as angle of
Angle of
reflection. I and R always equal. Either surface is smooth or irregular. Okay? It will
yes.
not vary. Suppose this angle is 60-degree. Then what will be the value of angle I and R?
Angle I is 30 and angle R is also 30.
30-degree. Both will be equal 30-30 because normal make 90
90
degree
degrees.
angle with the smooth surface. Very good. Now, according to the laws of reflection, incident ray, reflected ray and normal all lie at the
Same
same
place.
point, same plane, and we can observe it is at the same point. And first thing I told you, angle of incidence and angle of reflection are equal. So this is the phenomena of light. Okay,
Yes,
in
ma'am.
our syllabus only two, reflection and refraction. I told you about the reflection. Okay,
Yes.
Tanya, reflection is shown by the mirror. Okay, one more thing, Tanya, as shadow is formed. Why? Because light shows straight line propagation. Suppose here is any object and light is coming in straight line, so there is hindrance in the path, so here this shadow will be formed. Okay, so
Yes.
light is straight line propagation of light. We will study more about the reflection. Reflection, it is shown by the mirror. Reflection shown by the mirrors. Laws of reflection I told you, by mirror. Tanya,
Yes, ma'am.
plane mirror you see daily. Everyone sees daily plane mirror. So what you observe about the image formed by the plane mirror?
Um, it is erect
Huh. Image formed by the plane mirror is erect. Hmm.
and it is virtual, like it's behind the mirror.
Huh. It is erect. And Tanya, one more thing. Erect and virtual are connected. If image is erect, definitely it is
Virtual.
virtual. Hmm. It is distance. At same distance as the object. Suppose object is at 5 centimeter. then
In
image,
front of the mirror, then the image formed is as far behind
ha,
as object
ob,
distance.
object distance. Suppose here is the object, this distance 5 centimeter, 5 centimeter, then image will also be at 5 centimeter.
Mama, remember in the first test they asked this in an MCQ?
Hmm.
They asked the distance between the object and the image formed.
Very
I
good.
did not read that it was between the object and the image form, so instead of writing 10 centimeter in this case, I had written 5 centimeter.
Oh, it will be 10 centimeter. Again and again, I say, Thanya, that we have to be very careful while reading the questions. And
Yeah.
we have to do more and more sample papers so that we can determine which type of questions we will get in the examination.
Yes, ma'am.
That's why I say many times during every class. Tanya, now we will study about the spherical mirrors. As it is clear by name, spherical. Spherical means
Curved.
curved and it comes from a sphere. Tanya, I will tell you each and everything and you will get all the things. Tanya, this one will be formed from a sphere.
Yes, ma'am.
This one is a convex mirror. If it is bulging out, this one, it is convex mirror.
Yes, ma'am.
Okay. Tanya, as it is, as we complete this sphere, suppose center is here, from for the sphere, okay, center is here, it is known as center of curvature, and half of it is known as focus. When we join this line, this point is known as pole, this distance f, pf is focal length and fc is distance between focus and center of curvature, and PC is radius of curvature. So we can say radius of curvature, radius of curvature is double of focal
Focal
length.
length.
Okay, and
Yes, ma'am.
convex mirror is also known as diverging mirror. Convex mirror also known as
Diverging mirror.
diverging mirror. Why diverging mirror?
Because it diverges the light rays.
Diverges the light ray. How? It will strike to the surface and it will go like this. It will appear that it is going towards the
No,
focus.
focus.
Are you okay with it?
Yes, ma'am.
And this one is concave mirror. Concave mirror also known as
Converging mirror.
converging mirror. Why converging mirror?
Because it converges the light rays in front of it.
It converges like this. Light rays are coming. Firstly, I will show you this one. This one is known as principal axis. This one P, here center of curvature, and this one focal length. So all rays will go towards the
Focus.
focus. Okay, this one is
Yes,
known
ma'am.
as converging mirror. Tanya,
Yes, ma'am.
to for this one, question is asked in the examination. Suppose a paper is kept at a point, hmm, at
Mm.
a point of concave mirror, and it starts burning, then this point is known as focus. Sun rays are coming, activity we have done, sun rays are coming,
Yes,
all are
ma'am.
focused at some, at a point, converged at a point, this point is known as focus of the concave mirror. Here paper starts burning. Okay,
Yes, ma'am.
so Thania, pole, you know, center of the reflecting surface is known as pole.
Yes, ma'am.
PC,
is radius of curvature.
PC is radius of curvature. PF,
Is focal length.
PF is focal length. And the distance of PF, pole and focal focus,
Is half of radius of curvature.
half of radius of curvature and equal to distance between F and C. Radius of curvature is double of focal length, or focal length is half of radius of curvature. Okay.
Yes, ma'am.
Radius of curvature, and here the distance between PF and FC is same as we have done on last turn.
Yes, ma'am.
Are you completely okay with these things?
Yes, ma'am.
What do you mean by aperture?
The diameter of the.
Aperture is simple. This angular length, the part which acts as mirror, is known as a-
Aperture.
aperture. Okay.
Yes, ma'am.
And aperture depends on focal length or not?
It does.
No, it is not.
Oh, sorry, it does not. Sorry.
Focal length depends on aperture because center of curvature depends on it, but aperture does not depend on focal length.
Focal length.
Activity 10.2 is important. You can get question as objective type. Okay. Y- to write anything, means to write about this activity. I already told you about this activity.
Yes, ma'am.
Next one, focus. Focus means this one is concave mirror, converging mirror. All parallel rays are coming and after converging, meeting at the same point. This point is known as focus, and distance between P and F is known as focal length. That's why if any paper is kept at point F, it starts burning. Okay?
Yes, ma'am.
And in case of convex mirror, all rays are coming, parallel rays are coming and diverges after striking the surface of the mirror, reflecting surface of the mirror, and appears that they are meeting behind the mirror at focus. Okay.
Yes, ma'am.
So this one for convex mirror. Now image formation. Aperture I told you. Okay.
Yes, ma'am.
One more thing, spherical mirrors whose aperture is much smaller than its radius of curvature. We are taking these type of mirrors for our activities, for our diagram. Okay.
Yes, ma'am.
Next is image formation by spherical mirrors. So 6 we will study for concave mirror and 2 for convex mirror.
Yes, ma'am.
So concave mirror or convex mirror, before studying about their image formation, firstly we will study about some points. Some point means this one is
Rules.
concave, this one is convex.
Yes, ma'am.
If ray is coming parallel to the principal axis after
It'll pass
striking
through the focus.
focus, and here for convex mirror,
It'll appear to pass through the
the
focus.
focus. And one more thing, Thanya, focus on this line. This one is normal. Sometimes this question is asked that the normal of any spherical mirror will go from center of curvature.
Ma'am, the normal is always in center of curvature.
Center of curvature. Actually, the reason behind this, normal is 90 degree
Yes, ma'am.
and spherical mirror it is cut from the
Center.
huh,
No, no. I mean,
cut spherical surface means sphere, we can say sphere. Spherical
yes.
mirror is cut from sphere. So this one like normal for sphere, this one the radius like this one.
Ma'am, we just did this theorem in circles.
And it makes 90-degree angle.
Yes, ma'am.
So normal will always go from center of curvature. And here, if it is it is coming towards the focus. After striking the surface, it will become parallel. We
Yes,
will
ma'am.
look that it is going towards the focus, but no, it becomes parallel. Center of curvature, as I told you, the line going from center of curvature is normal.
Yes, ma'am.
That's why ray going towards the center of curvature will go in the
Will reflect back through the same path.
same path because it is normal. Same for convex mirror.
So here angle I is 0 and angle R is also 0.
Angle, yeah,
Yes, ma'am.
angle I, angle R both are 0. And in this case, it will go obliquely. Obliquely means going like this and go will like this. Obliquely in the same pattern
Yes,
as the
ma'am.
mirror image. It will happen when ray is going towards the pole.
Yes, ma'am.
Now we will study about the image formation by concave mirror. Image formation by concave mirror. There are six conditions that will arise for concave mirror. In first condition, Tanya, revise with me. In first condition, object is kept. In first condition, object is at infinity. Then image will be formed at
F.
focus. And
Yes,
what will be the nature of the image?
it'll be
Highly diminished. I am writing in short
highly
form only,
diminished in point size.
point sized. I am writing in this way, okay? Because we
Ye-
have completely made the chart. This is only for quick revision. Are you okay with it?
Yes, ma'am.
So here same thing as we have done for focus. Rays are coming parallel and after striking the reflecting surface, they will meet at the focus. Okay?
Yes, ma'am.
For second one, when object is kept between
Beyond C.
infinity or beyond C, we can say, so image is formed between C and F. Image
Yes,
we can see it is diminished, real and inverted. If if object is kept at center of curvature, image is formed at center of curvature but real and inverted of the
yes,
same size. If object is kept between C and F, ray will go and image is formed beyond C and it is real inverted but enlarged.
yes, ma'am.
And if object is kept at focus, image is formed at infinity, real and inverted, highly enlarged.
Yes, ma'am.
And next one is this one. When is between F and P, image is virtual and erect and enlarged. Due to this case, dentists use concave mirror. Okay?
Ma'am, so in any, ma'am, when they ask to draw a diagram for uses of concave or convex mirror, I didn't know which diagram to draw. Is it always the last case
Last case, and
for
it
concave
depends.
mirrors?
A concave mirror,
If they
why
ask something related to the use of
use
concave
it?
mirror,
So concave mirror use this one. Why dentists use this mirror? If they are asking why concave mirror is used in, I think headlight of headlight of car, then we will make this diagram because all ray converges at a point.
yes, ma'am.
Okay, for dentist we make this diagram. So we have to read the question carefully, which condition is possible there. According to that we will make the diagram.
Yes, ma'am.
Okay. And Tanya, one more thing, you have to practice these six diagrams, that how rays are coming. Here rays are coming parallel. After striking, they are going towards the focus. Rays are coming like parallel. striking going towards the focus and center of curvature. Then here rays are coming. Okay, it
Yes,
is
ma'am.
going like this. It is going like this. Center of curvature going at the same path and going like this, going to the focus, going this one, focus and center of curvature same. You have to learn all these rays like this one, this one. Okay,
Ma'am, as the object moves closer to the mirror, the image is formed farther away.
further away, and in the last case
It
image
is
becomes
formed behind the mirror.
behind the mirror, virtual and erect. Are you
Yes,
okay with it?
yes, ma'am.
All things you got till now?
Yes, ma'am.
Okay, now uses of concave mirror. Concave mirrors are commonly used in torches, searchlight, and vehicle headlights to get powerful parallel beam of light. Okay,
Yes, ma'am.
they are often used as shaving mirrors to see a large image of the face. Dentists use concave mirror, and large concave mirrors are used to concentrate sunlight to produce heat in solar furnace. So, Thania, for first one, which diagram you will make?
Ma'am, this one won't be the last case, no, ma'am.
For first one, concave mirrors are commonly used in torches, searchlight, and vehicle headlight to get powerful beam of light. So what happens here, Thanya? Source of light is kept on focus, and after striking the surface, it will become parallel.
Oh, so we have to choose a diagram with reflected rays parallel to the
Refracted rays
light.
parallel. For second and third, shaving mirrors and concave mirror by dentist, you will choose last diagram where where virtual and erect image is formed. And for the last one, large concave mirrors are used to concentrate light, so you will use this one. Parallel rays are coming, it will go towards the focus. Parallel rays are coming, it will go towards the focus. That's why in solar furnaces high matlab sunlight is concentrated to one point. Okay,
Yes, ma'am. Ma'am, the object is at F for the first case.
for the first case.
Object is at F.
Means here light source is at F, so that it becomes parallel beam of light.
Ma'am, but the diagram in my notebook is not like that.
You made diagram for it?
Yes, ma'am.
Show me.
I was just checking our notes.
Okay, show me which type of it.
Ma'am, this one.
Tanya, it is same thing. Light ray going towards the focus. Show me again. Show me again. Parallel and then towards the focus and then center of curvature. Yes, Tanya, object is at F. You can prepare diagram according to that. No problem. I told you that one, but from here, are you getting the point? Source of light is at focus. एक second, Tanya, I will share my screen again. Give me 1 second only. एक second, Tanya. Tanya, it is same
Yes,
thing. You can show according to that. I will show you from here. What I told you that object is at focus, then
yes,
it is the rays are going to be parallel. So if object is at focus, after striking the reflecting surface, they will become parallel.
yes, ma'am.
Okay, so I told you like एक second. Give me 1 second only. I have to go there. Ha, you have shown this one. You can pick this diagram because we have done this one only at F. But if you are making in that way also, it will also be correct. Okay, I told you. एक second. This condition. Second one. If rays from focus, it becomes parallel.
So, this is the only case where
Ha,
the we get a parallel reflected ray.
parallel reflected ray when object is at focus. So we have done this one. This one also correct because in six conditions we have shown this diagram. So you can make this one also.
Yes, ma'am. So,
Okay.
either from the rules or either from this.
Actually, this one is preferable because it is given among six diagrams.
Yes, ma'am.
But that one also correct because from focus parallel beam of light we will get.
Yes, ma'am.
Okay. Now image. Are you completely okay with it?
Yes, ma'am.
Image formation by convex mirror. Tanya, for convex mirror, we have only two conditions. In these two conditions, if object is at infinity, image is formed at focus behind the mirror. This one highly diminished and point sized. Okay?
Yes, ma'am.
Virtual and erect. This one is the condition for the convex mirror that image will be virtual and erect. Always. Due to this property, convex mirror are also used as rear view mirrors. Here,
Yes, ma'am.
image is less and it covers larger area for view. Between infinity and the pole of the mirror, P and F diminished virtual and erect.
Ma'am, so for convex mirror, if they ask any uses in diagram, then it'll always be between infinity and pole wala.
Between infinity and pole.
Yes.
We will pick this diagram if they are asking why convex mirror is used as rear view mirror and show it with the diagram. So we will pick second diagram. Also full length image of tall building, tree, convex mirror. One such mirror is fitted in wall of Agra fort facing Taj Mahal. If we visit the Agra fort, try to observe the full image of Taj Mahal. Okay. Now use of convex mirrors. Convex mirrors are commonly used as rear view wing mirrors in vehicles. These mirrors are fitted on the sides of the vehicle, enabling the driver to see traffic behind him, her to facilitate safe driving. Convex mirrors are preferred because they always give an erect image, diminished image, okay, and wider field of view. This one, wider field of view because they
Yes.
curved onwards. Completely okay with it?
Yes, ma'am.
Principal focus we have done. Now, radius of curvature of a spherical mirror is 20 centimeter. What is the focal length?
It's 10.
It's 10 centimeter. Third and fourth.
Name a mirror that can give an erect and enlarged image of an object. Convex. No, no.
Enlarged.
Convex.
No, no, no.
No.
Convex cannot give enlarged. We just done. Convex will give
Acha, it's the last case of the concave mirror.
concave mirror का last case.
Yes, ma'am.
Okay.
Yes, ma'am.
And convex mirror as a rear view mirror in vehicles.
Ma'am, they. Provide a wider field of view, enabling the driver to see the traffic behind them to
behind.
facilitate safe driving.
Hmm. Very good. Now we will do sign convention of spherical mirrors.
1 second, ma'am. Other than if they ask for shaving mirror, they mention powerful parallel beams of light. If there's another use for concave, then is there a different diagram?
For shaving mirror,
Yes, ma'am.
no same.
All the uses the same diagram, ma'am.
No. For first one, we put source of light at focus, and after reflection, rays become parallel.
Yes,
So
ma'am.
for that one,
I
first, second, third, fourth, fifth diagram.
fifth diagram.
Fifth.
Yes, ma'am. Object position at F. Then there are
And
last users also there, no, ma'am. Solar furnace and all.
solar furnace, we will do first diagram because rays are coming parallel, and after reflection, they concentrated at the same point. They converge at the same point. That's why more heat is produced.
Yes, ma'am.
Okay.
Yes, ma'am.
And last one for dentist and as a shaving mirror. For dentist, and as we are using it as a shaving mirror. Okay.
Yes, ma'am.
Now, sign convention of spherical mirror. This one. Tanya, you remember about the coordinate geometry?
Yes, ma'am.
So this is the same as coordinate geometry. In coordinate geometry, we have Cartesian plane.
Yes, ma'am.
So here P is considered as origin. Distance towards the right is positive. You remember like this. This one is positive, positive. This one negative, negative.
Yes,
Okay.
ma'am.
So and distance towards the left is negative. Okay.
Yes, ma'am.
Object is like this one. So this one is positive
Yes,
and
ma'am.
height downward is negative.
Negative.
Okay. So if we are getting negative, it means image is real and inverted. Magnification में negative. Positive, it means image is virtual and erect. Tanya, suppose magnification is -2. So it doesn't mean that it is less than 1. It means minus sign shows that image is real and inverted, and 2 shows that the image is magnified.
Yes, ma'am.
And this one is the mirror formula. 1 by V plus 1 by U is equal to 1 by F.
Ma'am, why, ma'am? It's not less than one. In my notes, we've written that if M is greater than one, image
Yeah,
is magnified. But
value 2. It is greater than 1. Minus sign
acha,
shows
we won't see the sign, only the value.
only the value. Suppose it
Acha,
is
okay.
like 0.5, then image is diminished.
Yes, ma'am.
Okay, now magnification. Magnification, as I told you, M is greater than 1, image is magnified, less than 1, image is diminished, equal to 1, image is same. The
Same.
condition, like if object is kept at center of curvature, then the same size image will be formed. Formula of magnification, h dash upon h means height of object upon height of image upon height of object, or minus v by u, distance of image upon distance of object. Okay.
Yes, ma'am.
Now example 10.1, read it and try to solve it.
A convex mirror used for rear view on an automobile has a radius of curvature of 3 meters.
Hmm.
If a bus is located at 5 meters from this mirror, find the position, nature, and size of the image. Uh, U is 5 meter.
एक second. A convex mirror used for rear view of an automobile has a radius of curvature is,
U will be minus 5 meters because it's on the left side.
and radius of curvature is 3 meter. Then its focal length will become
Uh, 1.5.
And positive, negative in
Focal length
case
will be positive.
of convex mirror. Very good, because it is towards the right side, and you told me you will be
Minus
minus
5 meters.
5 meter, and we have to calculate position.
Position, nature, and size of the.
What is the formula, mirror formula?
Uh,
1 by v plus 1 by u
1 by u is 1 by f.
is equal to 1 by f. Put the values. Can you solve it?
Mom, can you help? Mom, I don't know why I don't know how to solve physics
Okay,
numericals.
okay, no problem. So we have to calculate for the value of v. So we will write 1 by v is equal to 1 by f minus 1 by u.
Yes, mom.
1 by f means 1 upon 1.50. एक second, I have to erase it again. It is showing like this. It will become 1 upon 1.50. Okay, minus 1 upon minus 5.00.
Why can't we just take it as 1.5
Yes,
and
you can take, no issues.
minus 5.0 only, no, mom?
Yeah, you can take. Only 5 you can take.
Okay.
So it will become 1 upon 1.50 plus 1 upon 5,
Why, mom?
because
Actually, the minus and minus sign will make it plus.
positive sign. Very good.
Acha, okay.
You can write it as, you can eliminate the decimal. 0 will be cancelled out. So it will become 10 by 15 plus 1 by 5. LCM of 5 and 15 is
Uh, 3.
5 and
No, sorry, 5 and 15 it is.
15 only.
Huh.
So it will become 10 plus 3 means 13 upon 15,
Yes, ma'am.
or we can say V will become 15 upon 13.
Why, ma'am? Why we?
Because here it is 1 upon V,
Yes, ma'am.
so we will take the reciprocal.
Okay.
15 upon 13. Value will become, divide 15 by 13. What you will get?
1.1.
5. 1.15.
Ma'am, once can you do the division and show me?
Okay. 13, 15. Can you see?
Yes, ma'am.
13 ones are 13.
Yes, ma'am.
15 minus 13 will give you 2.
Two.
Point 0. 13 ones are 13.
Yes, ma'am.
Subtraction of 12 and 13 will give you 7.
Yes, ma'am.
13 fives are 65.
Acha, I forgot that after you put the decimal point, zero will come again automatically.
Huh. You can leave it here because up to two decimal places and it will become plus 1.15.
Yes.
1.15 meter. This distance is positive. So image is formed back of the mirror as the convex mirror. Image is always formed back of the mirror.
Sorry, ma'am, I was in mute. I said that it would be virtual and direct as it's from behind the mirror.
Behind the mirror. And in case of convex mirror, always remember that is image is formed behind the mirror.
Yes, ma'am, but in concave mirror, there is one case where the image is virtual, no, ma'am.
Yeah, last one.
Yeah, but how will, like in numericals, but if we get it as a positive,
If
we'll always write convex mirror only.
huh,
Like, is there any chance that from the numerical we will conclude that it would be from the concave mirror,
on
last case of it?
yes, because in case of convex mirror, image is always diminished, positive. Okay?
Oh, so by seeing the value, we will.
By seeing the value. In case of concave mirror, we have only last condition in which image, but in last condition, magnification will be more than 1. Are you getting the point?
Yes, ma'am. Ma'am, like if there's a decimal point, then it would be less than one.
Suppose zero point 0.5, zero point 0.3 in that case. Suppose it is 1.5, then it is magnified.
Oh, okay, ma'am. So here the image is magnified.
In case of convex mirror, you are telling concave mirror. In case of concave mirror, image is magnified.
Okay, ma'am.
Huh.
Ma'am, so here it is diminished.
Yeah, because it is case of convex mirror. Size of the image they are asking. We will
Acha,
tell.
they mention it in the question, right?
Yes, yes, they mentioned. Magnification is minus V by U.
Yes, ma'am. Ma'am, so I'm asking just for the value itself,
Huh.
but the same value with two different mirrors, it will be magnified or diminished.
Yes.
So it's not based on the value, sometimes it's based on the type of mirror.
Ye- means in case of concave mirror, it will be magnified. Wait, wait. We will solve it. देखो here value of V is 1.15 positive.
Yes, ma'am.
U is given 3 meter, but it is negative.
Yes, ma'am.
Minus minus will become positive.
Yes, ma'am.
So it will show that the image is erect. If image is erect, it means it will be virtual. And when we will
Yes, ma'am.
solve it, we will get the value plus 0.23, which is less than 1. That's why
Acha.
image is diminished. Plus sign shows that the image is virtual and erect.
Yes, ma'am.
Okay?
Ma'am, so if because of the sign change and
Hmm.
we won't get the same value.
Uh, s- because of the sign change means
If we are given the same object distance and focal length
hmm,
for both concave and convex, in the end,
yes,
the values will be different.
yes, yes, yes. Because
Acha, okay.
in convex mirror it will be diminished,
Okay.
but in concave mirror it will be magnified.
Magnified.
Now try this one. Example 10.2. Tanya, you have complete chapter reflection and refraction.
Yes, ma'am. Everything is there. Mirrors, lenses,
Oh,
refraction also.
okay. Tomorrow we'll continue same thing.
Yes. Ma'am, here they gave H value, right?
Yes, 4 centimeter in size.
Object distance is 25 centimeter.
It means it is
Uh, Negative minus 25.
huh. So here,
And H is positive.
huh, because object is always kept erect.
And focal length is 15 centimeter. That means we get the radius also. It's 30 centimeter.
Huh. And this is for concave mirror. So U is negative in front of concave mirror of focal length. So focal length of concave mirror is taken as negative.
Yes, ma'am. Minus 15 and radius will be minus 30 centimeter. Find the nature and size of the image.
Hmm. So firstly, what distance from the mirror should be a screen be placed in order to obtain a sharp image? Means you have to calculate for the value of V, find the nature and size of the image. Will you solve it?
We should find the image distance.
Yes, because they are asking where screen be placed in order to obtain a sharp image.
Okay. So we already have the object distance. We need the image distance to say that.
Yes, because at that point we will keep the screen so that we can get sharp image.
Yes, ma'am.
Will you solve it for the value of V?
Yes, ma'am.
Okay.
Ma'am, can you do it along with me? I have a small doubt.
Okay. So what is the mirror formula?
1 by V plus 1 by U is equal to 1 by F.
1
So we'll take 1 by V is equal to 1 by F minus 1 by U.
1 by V is equal to 1 by F minus 1 by U. And 1 by F?
Is 1 by minus 15.
Hmm. And minus 1 upon minus 25. Now can you solve it?
Ma'am, it'll become 1 by minus 15 plus 1 by minus 25.
Plus, plus 1 by 25. Minus
Plus
minus.
1 by 25.
Now we will take LCM of 15 and 25.
It would be 15 into 25.
No,
Acha, uh,
LCM. You can take 15 into 25, but it is simple. 5 threes are 15. It is showing again. 5 fives are 25. It will become 75. 535 will become 75.
yes.
Are you solving?
Yes, ma'am.
Okay.
Ma'am, can you finish the rest of the sum?
75 you have taken as LCM?
Yes, ma'am.
Okay. So it means it will become 15 fives are 75 minus 5. This one will become 15 fives are 75.
Yes, ma'am.
Now 25 threes are 75. So it will become, sorry, plus 3. So it will become minus 2 upon 75.
Yes, ma'am.
Divide 75 by 2. We will get minus 37.5 centimeter. Okay.
Yes, ma'am.
We will become minus 37.5 centimeter. This is
Ma'am,
the
so images
the distance of image.
magnified.
This is the distance of image.
So sorry, sorry.
And it is with negative sign. So it is towards left side.
Left side.
This is for concave mirror.
Yes, ma'am.
So it is left side. Now, uh, uh, first answer we calculated what distance from the mirror should a screen be placed in order to obtain a sharp image. Find the nature and size of the image. So nature will be real and inverted because it is at the same side.
Yes, ma'am.
So real and inverted will be image.
Yes, ma'am.
Now magnification. No, magnification. Firstly we will calculate about the magnification. Magnification is minus V by U.
Yes, ma'am.
What is the value of V?
It is minus 37.5.
Minus 37 point.
But since it's minus v by u, will make it plus
Yes,
minus minus.
yes, yes. But hmm, minus V by U. One more thing. Tanya, here we no need to calculate magnification. We have to calculate size of the image, which is h dash, and magnification also h dash upon h.
Yes, ma'am.
So h dash is equal to minus V. Value of V is, we just got, I think it is minus
Minus
37.5.
37.5.
U is
Uh, minus 25
mi-
centimeter.
minus 25 centimeter. And what is the value of h?
H is
4 centimeter.
Yes, ma'am.
So minus minus will be cancelled out. We will solve it, and 10, it will become 6 centimeter. Okay.
Yes, ma'am.
So size of image is 6 centimeter. It is negative means it is inverted. Inverted, then it is real.
Yes, ma'am.
Okay. And what about magnification? It will be diminished or enlarged?
It'll be enlarged.
Enlarged. Okay.
Yes, ma'am.
Tanya, revise
Yes, ma'am.
these numericals after the class also.
Yes, ma'am. Today I will be finishing up. Ma'am, during the weekend I'll do light, ma'am, because I have a social exam with 4 chapters in this Tuesday. So if today I'm doing mirrors, then tomorrow I'll revise lenses like that.
Okay, okay. And mirror, some 2 or 3 numericals will do of mirror in tomorrow's class also. And
Yes,
after
ma'am.
that, we will start refraction. You have test on Friday.
Yes, ma'am. This coming Friday.
And before that, is there any holiday?
Monday's a holiday, ma'am.
Why?
Bonalu, ma'am. It's a festival here.